Alright, we're back for part 2 of graphing equations from a table. Like I alluded to in the last video, these functions aren't linear. If you haven't picked up on the word linear yet, linear means line, a straight line. And so these, I'm telling you right away, we won't get a straight line. We're going to do two weird looking shapes. That way you can still do some weird looking shapes in the rest of the notes packet or on worksheets on your own, and so you can start to really figure out what's going on. But I'm hoping from these videos you're starting to figure out ideas and plans for what to plug in for X. I'm hoping you're starting to catch on at how to use your calculator or mental math to input values for X and to find out what the output Y would be. And I'm also hoping that you're catching on to how these graphs shift from the parent function. That's called the transformation. This is the parent function for a parabola. We're also going to look at the parent function of a cubic. So you're going to start to see what things look like. Let's again try 0. Now if I plug a 0 in for X, 0 squared. I would recommend, if you're using your calculator, now this is an easy one, if you're using your calculator, put all numbers in parentheses, because when you start to square negative numbers, you're going to get some weird things, especially when you go to the next picture and you start to cube negative numbers. Some weird things happen. So I'd recommend let's use parentheses. Anyhow, 0 squared though, 0 times 0 is definitely 0, would always be 0, and so we can plug 0, 0. 1 squared, 1 times by itself is 1, so 1, 1. It looks like I'm starting to get that diagonal line, so I definitely need to graph more points, especially because I told you this is not linear, meaning it's not going to be a straight line. So let's try it. Let's get ambitious here. Let's try 3. If I square 3, 3 times 3 is 9. So that means here at 3, I'm all the way up at 9. There's 3, there's 6, that's 9. And so, you know what, let's fill in that blank. Let's put that 2 in that we skipped over. And when I square 2, I get a 4. And so that puts me right here. And so now I'm starting to hope you see that is definitely not a straight line. And even if I get my ruler out, I certainly can't make a straight line through all of them going that way. When I start to go up through here, I can only hit 2 of them. Look, I'm definitely missing that one through the origin. If I go through these 2, I miss the one on the origin and the one up here. I won't be able to make a straight line through these points, but I don't know exactly what it looks like yet, so I'm going to have to plug in some negative values. Let's try negative 1. If I square negative 1, again, really, I recommend if you're using your calculator, put this in parentheses, because when you square negative 1, think about it mathematically, and here's why I say your brain's smarter than a calculator. You know what negative 1 times a negative 1 is. It's a positive 1. But if you forget those parentheses, your calculator should tell you that that's a negative 1, which is wrong. You want the parentheses. You want the number negative 1 to be squared. Negative 1 squared gives me a positive 1, which means, look at that. Definitely not a straight line. I'm coming back up again. Let's try that negative 2 value. Negative 2 squared is a positive 4. So negative 2 gives me a positive 4. Look at what's happening. I'm coming back up on the other side. And if you were paying attention when I told you this looked like a parabola, you would know a parabola has that U-shaped figure. It comes down here and it makes like a little U and comes back up on the other side. And so that's the parent function for a square. Okay? Keep that in mind. Now let's look at a cubic. Y equals x cubed. Again, when you do this on your own and you're plugging in input values, other than 0, I'd be using my parentheses on my calculator every time. 0 is easy because, again, all a cubic means is I need x multiplied by itself 3 times. So 0 times 0 times 0. Well, 0 times 0 times 0 is 0. That's an easy one. And honestly, when I plug a 1 in, 1 times 1 times 1, also pretty easy. That's a 1. And again, looks like could be the straight line, could be that U shape, I don't know. I got to plug in some more values. So let's plug in 2. Well, this time 2 times 2 times 2 is not 6. 2 times 2 is 4, times by another 2 is 8. I get the value 2, 8, which would be all the way up here. So, could certainly be some sort of U shape. I definitely need to try some negatives. Let's try -1. Now, here's where you're going to want to use your parentheses, because if you cube a -1, -1 times -1 is a +1. But I need to multiply that +1 by another -1. -1 times itself 3 times is a -1. So that means I get this point over here, -1, -1, and I definitely don't have a U. And I can certainly tell that by plugging in -2. -2 yields a -8. That means I'm all the way down here, and so it does look like it has some sort of symmetry. Looks like they reverse each other. This creates what I like to call a paperclip. Because if you took a paperclip and unfolded it, it would look something like that. That's just like what I call it. But you certainly don't get a U. That is the base shape. That is the parent function for y equals x cubed. So we got two more. A little bit harder a little bit harder square, and then a little bit harder cube. So keep in mind what happened last time when we were adding and subtracting values. Let's try 0 to start. Always an easy value to pick. When I plug a 0 in here, 0 plus 1 is 1. 1 squared, 1. Let's plug a 1 in. 1 plus 1 is 2. 2 squared is 4. And let's try one more positive value. If I plug a 2 in, 2 plus 1 is 3. 3 squared is 9. And let's go ahead and plug those in. 0, 1. 1, 4. And 2, 9. Looks like it could be close to a straight line, and it really is close, but it's not quite a straight line. Especially you can tell right there if I were to, so it's not quite a straight line. Plus I know when I see that square, I'm thinking that this is going to be some sort of U shape. So I would recommend, let's plug in some values over here on the x-axis to see if this graph doesn't come down and swoop back up. So let's try -1. When I plug a -1 in, -1 plus 1 is 0, and 0 squared is 0. So that doesn't help too much. I still look to be going down this side. I want to find that vertex. The bottom of that U is the vertex. Let's try -2. -2 plus 1 is a -1. -1 squared is a +1. So -2, 1. There it is. You can start to see it's coming back up. Let's just try one more for good measure. Let's plug in a negative. Let's try -3. -3 plus 1 is a -2. -2 squared is a +4, which means I would have the point -3, +4, definitely starting to come back up again. And so now if I draw this, you can really see that U-shaped picture. Last one. Let's go ahead and graph the cubic y equals negative. So right away, I'm going to stick a 1 there, because that's kind of like I have a -1 out front. -1 times by x minus 2, and that's all being cubed. So again, I see that's a cubic. I'm thinking some sort of paperclip shape. Alright, let's start with 0. Always a good number to choose. And let's show some work for this, so that you understand what I'm talking about as I'm saying it out loud. We have a -1 in parentheses, 0 for x, minus 2, that's all being cubed. So I would have to take 0 minus 2, which is a -2, and then I need to cube that. Well, -2 cubed is -8. Now I have a -1 times by a -8 because I'm following my order of operations. So that means y is equal to a +8 when I plug in 0. That is nothing we've seen before, so we need to be very careful when I start to graph this function, because my first point was 0, 8. That is a very large number compared to all the other ones we've gotten when we plugged in 0 as our input. So let's go ahead And let's try another positive number. Let's plug a 1 in. 1 minus 2 is negative 1. Negative 1 cubed is negative 1. And negative 1 times negative 1 is positive 1. So all of that math gives me 1, 1. Which is really interesting because this does not look like a paperclip. So we're going to definitely have to try some values to the left of 0 and some more yet to the right. So let's try another 2. 2 minus 2 is 0. 0 cubed is 0. 0 times negative 1 is 0. When I plug a 2 in, I'm getting 0. Okay, that's at least a good sign because it looks like I'm getting some sort of curve. Let's go ahead and try a negative number right now. Let's see what happens if I plug a negative 1 in. I want to see what's going on over on this side. And this is how you handle all of these. You try to think about what this shape should be, and you try to figure out what are good values to choose. If I plug a negative 1 in, negative 1 minus 2, negative 3. Negative 3 cubed, I have to get your calculators out for that one. Negative 3 cubed is a negative 27 times by a negative 1. That's a positive 27. I do not have room for that. That is over here and all the way off the paper. So that means it's coming down right like this, coming down really steep. It's coming down through these points. Now, I have no idea where it's going next. Will it turn back up and be a U? Or maybe it'll flip and it'll be like a backwards paperclip. And I'm saying that because if we quick look at this first paperclip function we did, look at this and you see how it went from right to left. Well, this one's going from left maybe to right, so we'll have to see. I'm going to put my arrow on here to show that this goes forever. We're going to have to see. Let's go ahead and plug in another number bigger than 2, so let's try 3. 3 in for x. 3 minus 2 is 1. 1 cubed is 1. 1 times negative 1 is a negative 1. So that means I have the point 3, negative 1. Look at that. One more for good measure. Let's plug in 4. If I plug in a 4 up top here, 4 minus 2 is 2. 2 cubed is 8. 8 times negative 1 is a negative 8, which means I have the point 4, negative 8. That would put me down here, and I definitely get that paperclip looking shape that bends left to right. So keep in mind, look at what happened. I have this negative sign on the outside. Remember what negatives mean. I'm going to take the opposite. So that picture that originally went right to left, still same idea of the paperclip, but it went opposite of what you thought, left to right.